Welcome to the second session of the last day of the eFlight Forum China 2020. Our subject this time is UTM and other enabling factors for UAM. So UTM, for those who are not familiar with the term, as urban air traffic management. And our first speaker is Corvin Huber, who is the CEO and founder of D3, which is a company which has made the goal to make to solve this problem, which definitely will be there because you cannot have urban air taxis flying with a nowadays control system, because nowadays, like the air traffic management, it's for large aircraft outside cities. It will not work. But Corvin, I'm sure you can explain this much better than me.
Hello, Willy. Thanks for letting me be here. Can you hear me?
Yes, I was muted already. Yes, hear you perfect. Fine. Thanks.
All right. Is it okay to share a screen?
Yes, that's what we expect.
Very good. Can you see full screen now, Willy?
Yes, perfect.
Excellent.
Affirmative.
Thank you very much. Well, again, hello to everyone who's listening. I'm very pleased to be able to present our startup company. We've been around for about 9 to 12 months now, a little more with preparation time. So we're a newcomer to the field, but you will find out in a few moments that we believe that we can bring a lot to this grand new venture of aviating urban skies. Close your eyes for a moment and imagine a mega city in 2030, 70 plus landing fields, over 2,000 taxi drones in the air, no room for errors in navigation, no pull over if something goes wrong, no parking until everything is over. What does it take to make this kind of traffic happen? Urban airspace is dense, complex, and totally unforgiving. The well-known human pilot controller interaction is not a scalable proposition. No comprehensive solution has been proposed to this point, although a lot of ideas are being circulated. Air traffic control needs to be rethought from the ground up. My name is Corvin. I'm the co-founder and CEO of D3 Technologies AG. I'm an aerospace engineer by trade. I've had the good fortune to manage several aircraft manufacturers during the course of my career. And I learned from the very limited audience that we sold aircraft to that it is my new vision to allow a larger demographic to benefit from the concept of flight. This is why I made it D3's mission to actually enable automated and uncrewed passenger transport. That is passenger flight without a pilot. The key word here is that passenger transport for compensation, which brings with it very high safety requirements. This is a fascinating technological challenge, obviously, and at the same time, we need to ensure that urban air mobility serves society as a whole and will not become a privilege for a very few. So, how do we manage a large number of vehicles safely and responsibly at a scale that classic air traffic control was never really intended for? We're busy designing and building a system that efficiently solves these challenges, and it is based on the concept of automated distribution of safe air routes and mechanisms to ensure adherence to these routes. It is safe and certifiable. It allows cities to maintain control over their airspace, and it integrates existing service suppliers. Briefly, what the image that you're looking at is intended to show is that we believe there needs to be a central clearing position that makes sure that intended routes are mutually compatible. We do not believe that fully autonomous behavior on part of the vehicles, being able to decide ad hoc what their best course of action is, will lead to an efficient overall system. So we are basing our navigation solution on deterministic planning of routes, last not least because we believe this is the most certifiable approach. We also believe that the environment needs to be integrated, the city that we operate in needs to be able to superimpose high-level rules of where to fly, where not to fly, when not to fly. The city needs an ability to keep certain spaces clear of traffic and condense traffic in other areas, which again heightens the requirements for traffic management in those condensed areas. At the same time, we need to integrate the classic aviation information bases, such as positioning, airspace provision, known airspace and ad hoc airspace, weather services, etc., etc. Our system solves this through an integrated communication backbone with APIs that are available to all the players in the system, combines this to a unified air situation image upon which the decisions will be made for routing or for route acceptance. And we'll be hearing a little later from our friend and colleague Frank Anton about digital twins. While I think Frank will talk a lot about digital twins for technological development, we are seeing a kind of digital twin here in the center of a system that actually reflects all known information, and not only all known information, but actually all information that is required to make acceptable navigation decisions. Cities will benefit from the fact that they can open and control their airspace and safeguard public benefit by superimposing high-level rulings. Fleet operators can plan and conduct flights efficiently and in real time, and operate vehicles in a safe and very accessible system, ensuring operational safety. And in the end, you will be able to fly wherever and whenever. Our business model is fairly simple. We provide air traffic control for metro regions. Fleet operators will pay for our services. The revenue stream is based on our service of providing safe and navigable routes. Additional value streams based on our technology are fully available and can be rolled out at a later point in time. We have generated engineering traction by building what we call a simulizer, a combination of a simulator and a visualizer. It's an engineering tool that allows us to validate our development in a simulated virtual urban environment and allows us to visualize our system approach and communicate the impact of urban air mobility on cities. We are presently demonstrating a complete functional chain of ground station communication network and airborne avionics on a lab scale, and we're looking forward to the next steps in our roadmap. We're looking forward to begin our flight test program in Q2 of 21. Here we will demonstrate in-flight an integrated functional chain of ground station communication backbone and airborne electronics. We expect a rollout to model regions as of 22 and first demo operations in 24. This time plan seems to us to fit a high number of known vehicle manufacturers' timelines, so we're quite excited being able to launch into this. Our company has recently received what we call seed funding, and this enables us to build our pilot application, our in-flight demonstrator. We have a number of very interesting, we believe, personnel, engineers on board. Otto, for instance, managed a very large-scale avionics program for Airbus. Ralf is a chief architect was the chief architect for the Deutsche Flugsicherung in Karlsruhe, one of the most modern digital air traffic control centers in Europe. So we're well equipped to manage a project of this size and scale. In a nutshell, our system proposal offers a convincing and we believe quite superior concept because it is designed from the very first with the final goal of automated passenger transport in mind. It offers measurable added value to all stakeholders, such as cities, fleet operators, and vehicle manufacturers. And last but not least, it is very scalable since our basic development effort can be rolled out to a large number of locations. So we'd be happy to answer any and all questions that you may have. We believe that this type of urban air mobility is coming and our solution will be available when the cities need us. Billy, thank you very much.
Thank you, Corvin. And very interesting. And I think I will have some questions later in the Q&A sessions. Now we move on to our next speaker, who is speaking about the same topic from another perspective. And this is also what we always try with the eFlight Forum, having industry, startups, and researchers who work in the same field because they have to work hand in hand to getting things solved. For Dr.Bianca Schuchardt, yeah, Schuchardt from, I get English accent talking too much English. She is working for the DLR, which is Germany's largest aerospace research institute. And Bianca, please give us the scientific. I saw the image right before. Now I don't see the image again. I see Corvin's image still. Now, if you can get Bianca's image on and the sound on, then I think we are perfectly set. Okay, so please then present for us.
Okay.
Bianca,
Thank you
do you
very
hear me?
much.
Yeah, okay,
yes,
perfect.
I can hear you. You can hear me?
Yes, a little bit. Yeah, it's okay. Thank you.
Okay. Yeah, thank you very much for the kind introduction and thank you for the opportunity to present our research project here. It's an honor for me to speak to this international audience today. I hope you can already see my first slide in the background. I'm not sure if I have the control over the slides, so will you forward the slides for me? Ah, yeah. Okay, perfect. So as Willy already said, I'm a researcher from DLR, the German Aerospace Center. I'm pretty sure that my German colleagues in this session, they have heard of DLR before. I'm not sure how well known DLR is in China. So let me say a few words about DLR. We are a research institution as well as a space administration at DLR. And our focus of research lies on aeronautics, but also on space research, technology, transport, energy, security, and digitalization. But the aeronautics and space research is the major part of our research program. We have more than 9,000 employees in 54 research institutes in Germany, and we are spread over 30 sites in nice Germany. So many researchers working on diverse topics, and today I want to present on the project HorizonUAM. Yes, thank you. It's a recently started research project here at DLR. It's focusing on urban air mobility and especially on air taxi services. So we are looking onto air taxis carrying, on drones carrying passengers in form of an air taxi service. It's in DLR internal research project and it was initiated by the DLR executive board. So this means that DLR feels that there is a research gap that we should fill with a project, especially focusing on urban air mobility. We have just started our research this summer and the project will run 3 more years. So today I cannot present many results yet. So we were still on the definition phase. It's more that I will present what we are planning to do in the next 3 years. We are glad to have 10 different DLR institutes involved in our project, so we can cover a variety of UAM topics within this research project. And on the right side, you see the main parts, the main topics that we will focus on with our research. And I think this fits well to the 5 key enabling factors that Mike has presented us this morning. The key elements of what urban air mobility needs to become successful. That is on the one side, the vehicle itself. Of course, we need new vehicles. We have many designs already out there. They need to be built, they need to be operable, but they can't work without the necessary infrastructure around. So we need aerodromes, vertidromes, where starting and landing is possible. We need to think about how to operate these vehicles with the infrastructure. So what will the flight guidance concepts be? How dense can the operations be? Where are the economic effects? So when it's suitable for a company to invest in urban air mobility. And not to forget the acceptance. At least in Germany, we cannot create a new mobility system that is not accepted by the public. So it's important to involve the public and to create a system that is widely accepted and that is that can be used by a wide user group. As Mike said this morning, it's also true for Germany, this NIMBY, so not in my backyard. That's also a problem that would arise in Germany if we push things too fast, too forward. So it's important to get the public acceptance for whatever we create in urban air mobility. Could you please go to the next slide? Okay, this is the outline of the project content. I already said we are looking into vehicles. We won't actually build a vehicle, so we will keep it to theoretical layout of vehicle family concepts here, look into system technology and cabin design. We will have the vertidromes, so the infrastructure, flight guidance, the network management and airport integration. As I said before, acceptance is important. I talked about that, but we will also have a UAM system simulation. We already started with that. So we will have an overall system where we integrate all the ideas of the 10 institutes that are involved in this research and bring together our simulation models to forecast demand, the economic effects, and to see how the UAM system can be operable. Very important is the aspect of safety. And could you go one slide back? The aspect of safety and security, especially autonomy. In the first designs and the first vehicles, we will probably still have pilots, but if we want to have a high number of operations and if we want to have a future mobility system, we are envisioning a high level of autonomy, up to full autonomy without any pilot involved. So it's important to research on this autonomy topic and to research on how autonomy can be a certifiable process to be safely integrated. And last point to say is the demonstration and assessment. We are happy to already have a variety of simulators in DLR. We are working with virtual reality a lot. We have a tower simulator where we have a 360-degree scenery of tower operations, and we are planning to integrate our urban air mobility concepts there. We are also building up a new UAM cabin simulator where we can have different seating arrangement and see how passengers interact with the flight guidance options that we give them in a highly automated vehicle. And we're happy that DLR recently bought a small regional aircraft in Germany, and we are planning to convert this into a test site for drones and urban air mobility vehicles in the next years. So we will also have scaled flight tests here, not with real UAM prototypes yet, but with smaller drones to demonstrate our flight guidance concept and navigation concepts there. Now, yeah, thank you. I've brought 2 more slides with topics that I would shortly want to focus on. First is the UAM aerodrome, the vertidrome we are looking into in detail in our research. Well, I cannot present all of the research. It's too much, but just take this as an example of what we are doing. With the Vertidrome, it's the difficult thing is that we don't really know yet what a Vertiport, what a Vertidrome will look like. We know conventional aerodromes, but we don't know yet what a Vertidrome needs to look like if we have high density operations in the inner city area. So first thing is that we need to forecast the demand. How many vehicles will be flying? Where will they be flying? Where are the best locations for our UAM aerodromes? Where do we have to place them in the city or around the city? Then it's important to know what kind of vehicles will be landing there. It's all vertical takeoff and landing. Do they need some short runway? So this will have big influences on how to design the Vertidrome. And then when we look at the operation itself, here comes in the flight guidance part of our research. So what is the layout of the perfect Vertidrome, scheduling, sequencing, how to manage the flay, the approach, the departure path, the trajectory planning. So this is something that we will look into. And then in the end, we have to come up with new regulations. We have European regulations for helicopter operations, for example, but we do not have ready regulations for UAM. Operations. So this is in the process to be developed, and we hope that our research can also bring ideas into this regulation initiative. If you can go to the next slide, please. Yes, that's the second part. Well, the session is called UTM. That's the term that is more common in the US, I think. In Europe, the term U-Space has been created. That is the vision of the European Union to have a set of services designed to support safe, efficient, and secure access to airspace for large numbers of drones. Well, the initial idea was to have drones, but if we have a highly autonomous, up to fully autonomous urban air mobility vehicle, we can see it as a drone. This U-Space concept, these services, they are supposed to provide the enabling framework to support routine UAM operations as well as drone operations, and to provide interfaces for also to manned aviation. And what is important to say is, although it's called U-Space, we do not see it as a defined volume of airspace. So of course, in the beginning, we will need some segregated airspace for the first trials, but the goal is in the end to have no limited airspace for certain times of users. So the goal is to have a fully integrated airspace for all kinds of users. And the U-Space concept foresees to develop the services that we need for this in 4 steps. We are currently at the first steps, U1. So we have foundational services that would be something easy to start with, like e-registration of drones, e-identification of drones, geofencing. So that is the starting point. And within the years, the EU envisions further services to be developed up to the U-Space full service level, and that would be the complete integration of drones, urban air mobility vehicles with conventional manned aviation. But it's still a long way to go, so there's lots of research that we need to do in this area, and I hope that our HorizonUAM project can bring new insight into this. Could you go one slide further, please? Sorry. Yeah, there it is. Yeah, that's what I wanted, exactly. Let me quickly tell you about the project phases. I said it was a 3-year project, so we are now in year 1. We are still working on the theoretical basis, gathering knowledge together. Year 2 will be more into the implementation, getting our simulators ready, preparing our demonstrations, and then phase 3 up to the year 2023. We will then have our drone demonstrations, our simulators ready for the final assessment. And what I wanted to let you know that we are planning for yearly symposia for a scientific exchange beyond the project boundaries. The first symposium was planned for September 2021. So if you are interested in seeing first results from our HorizonUAM project, feel free to contact me. I will keep you updated on what kind of, in what form we will plan the symposium and how we will share our research results. Okay, next slide, please. There's not much more to come.
Slide.
Yeah, just for your reference, I'm not sure if the slides will be published. You have 4 more references to further reading, and then it's my last page. If you go one further, that's just
Okay.
Thank you for listening, and I'm looking forward to your questions.
Thank you very much, Bianca. And I'm quite sure those people who work in this field will have some questions at the Q&A session afterwards. At this point, I say thank you, and I hope to have perhaps DLR on a regular base in our forums. For example, we had NASA before, and I think some more international cooperation definitely could also help to get everything forward. Our next speaker, Florian Holzapfel, he has been in our forums on a regular basis from the beginning. Florian is a close friend of mine, and I'm happy to have you here. So Florian, he's professor at TUM in Munich, and he's speaking about a slightly different topic, but it also has to do with enabling factors for UAM. So Florian, the stage is you, and I'm sure you can explain much better than me what you're talking about. Florian, are you unmuted? I saw you before, but now I don't see you. Florian? Florian, perhaps you have to accept that you're unmuted.
Can you hear me?
Yeah, now it's much better.
Okay. So then
you're a little bit low noise, so if you can speak a little bit louder would be great.
Okay, so thank you very much for introducing me and having me. Can you hear me now? Billy, can you hear me?
Yes, we see your screen.
And the voice?
And the voice is still a little bit weak.
Wait, I can just a second. Then I try here with the voice. Improve. Voice better now?
Yeah, much better now.
But now I start to rush through the slides to catch up. So basically my presentation will be in the sector of other enabling factors to UAM. So I will mainly talk about modeling and simulation. So it's a quite technical presentation, which I prepared for you today. And so the background is that, of course, eVTOLs are quite new and there's not too much technical learning curve yet. So not too much experience, but we still have a significant degree of uncertainties. And but still very much in the beginning, we already want to have a very high design confidence when we build a new vehicle. And it's not only important to account for the nominal dynamics, but especially if you want to make a product vehicle, also for the different failure cases. And therefore, we must carry on what we learned from small vehicles to big ones, but we need to take care of growth considerations. Then the next thing is that especially for large vehicles, we have to account for the correct dynamic order. We actively have to manage uncertainties in our models. We need to consider dirt effects that may make life hard. And as already addressed, we also need to consider failures. So this is a slide I already showed last year about the scaling factors. Many people are building subscale models and then think you can directly carry over the experience gained to larger systems. And so what I quickly would like to highlight here, if you compare, for example, a 25 kilogram vehicle and a 600 kilogram vehicle, that many of the properties, like for example, the propeller inertias and so on, do not scale linearly at all, which means that in many important numbers, you get very nonlinear scalings. And so, for example, if you want to make a sidestep maneuver of 5 meters in 5 seconds, for the 25 kilogram vehicles, you only need 2% additional current, whereas for the 600 kilogram vehicle, the increase in current is 50%. So I try to speed up. This is a short summary. Things don't scale linear, be careful. The next thing is you have a lot of new effects which you don't know from classical airplanes. For example, this time in hover, you have a lot of propeller airframe interactions. Then what is very important in transition is the propeller aeroelasticity, because it leads to very large alternating moments from the structural loading, which are acting in the hub of the propeller. Then depending on the configuration, and I'm happy that I saw some faces today from other companies from which I knew that they're also addressing these effects. As soon as you have overlaps in the propeller areas, for example, you immediately get significant thrust losses, which is something which you have to consider right from the beginning. Then here on the upper right side, there's transient effects, which if you look from their scale in the time are very relevant to be considered also when you look at the rigid body dynamics. And then finally, of course, in hover, you need 360-degree aerodynamics because you can have lateral gusts and things like that in hover. And so also for your fixed wing rigid body aircraft part, you need to account for aerodynamics, which you normally would never calculate for normal fixed wing airplanes. Then the next thing is that, of course, the structure is elastic, and now with the lift systems, especially under failure conditions where you have to redistribute, you have quite some excitation of structural responses, which lead to time lags in the rigid body response, and that also lead to aeroservoelastic effects. And this is why basically for the larger vehicles, these aeroservoelastic responses need to be considered right from the beginning. So far, you saw things which are mainly based only on simulation. Here on the next slide now, you would see measurements from the transition of a real 280 kilogram eVTOL. So that's the whole flight, hover, transition, fixed wing flight, retransition and landing. And so you see you have a large contamination with vibrations. And so one of the important things is if you want to optimize your frequency domain response for the controller is that you have appropriate methods to not only identify your vibration spectra, but also to produce models which in time domain simulations can make a very good replication of your vibration spectra so you can account for them during controller design. Then the next thing which I introduced already in the beginning is that there's a very high level of uncertainties in the data because of the lack of experience, and therefore we moved away from having nominal models, but for every model we make uncertainty modeling where we in the end use the stochastic characteristics of the uncertainties by specifying distributions and the values of these distributions, like normally distributed and so on. And so one of our researchers implemented, in my opinion, very cool, a new way in order to quantify then these uncertainties in simulation models, which then can be used in analysis for making probabilistic predictions. So for example, when you want to have the envelope which with a 99% or a 80% probability is trimmable and so on, you can now make all these flight mechanics and performance computations in a probabilistic manner, which helps you to set good design targets, for example, for maiden flight envelopes and so on. Then very important is what happens if you have failures. Here I want to acknowledge our partner Beihang University, Professor Chang and Ming-Kai Wang, who are helping us very much in our very close cooperation. And what you see here, again, I speed up, is basically the maneuverability envelope, which you would have within 3 seconds. This is the red area if no engine fails. And so the volume you see inside is the guaranteed remaining maneuvering envelope if any single engine of a certain eVTOL configuration would fail. And so this is very important to know because especially the precision in hover, which you have in a failed condition is very important. And just like this, we also look at the handling qualities, where for the hover case, for the time being, we take a classic rotorcraft handling qualities and we look which handling qualities requirements are still satisfied if we have, for example, one engine in operative. And so here, for example, you can see the hover heading precision, handling quality requirement, or the same thing, for example, for the altitude response. And once again, it's not about the nominal behavior, but it's especially about the behavior in failure cases. And to do piloted evaluations for these handling qualities, we mainly use mission task elements. And we are very happy to see that in ASTM F44.50, the task group WK68767, which is considering simplified vehicle operation, and also NASA and FAA, by the way, are also focusing on mission task elements as a very suitable way of doing the evaluation. Most of the time we use a virtual reality setup, so the pilot can look around and move the head, and basically we do a quite automated evaluation for this. And then finally, if you do flight tests, you want to do parameter estimation to update your simulation models from flight test. And this is what we're doing. And I think one of the new things we have there is that basically the identification routine is directly coupled with a blade element theory, a bottom-up physical model of the airplane. And so on the top right side, you see the identification results of one of my researchers for a Flatner rotor helicopter. And just to highlight you that this is also working very well in the eVTOL domain. You can see here from a flight test for a 400 kilogram transition vehicle from a real flight test from just last week, basically the raw measurements, which would be the blue dots, and the data you get with a smoother, which is really based on a model of the system. And you see that this, of course, for example, also would allow you to get a very smooth reconstruction of the angular accelerations, which is then the input step to identifying the physical parameters of the system. So to sum up, eVTOLs are outside the classical learning curve. The dynamics does not scale linearly with size, so you have to be aware of size factors. In larger vehicles, transient aerodynamics and interaction effects matter more than in small ones. The structural dynamics adds a lag and low damping to critical responses. This is why you have to account for it. And it also produces new load cases with the lift systems in hover, especially during failure cases. You need to account for the vibration spectra of the real vehicle if you want to optimize the response of the closed loop system with the controller in the frequency domain. Then the probabilistic uncertainty modeling allows you to make probabilistic predictions with which probability will a certain requirement be fulfilled to give you more safety in the background of the uncertainties. Then if you look at failures, it's not just sufficient to look that the aircraft still can hover after the failures, but you need to clarify what is the remaining maneuverability envelope and what are the remaining handling qualities. The mission task elements are a good choice for handling qualities assessment of these new types of vehicle. And then finally, optimal control allocation based on parameter estimation with physicals basically gives you a quite good match for the identified models. This is everything I wanted to say, and I hope that I did not exceed my red race time too much. Thank you very much.
Thank you, Florian. And I know, like always, good in time and very fast. So thank you again. And I hope you have time to stay for the Q&A, which we have afterwards. Our next speaker is like Florian. He has been at events of organized by Flying Pages very often in the last years in a different role. So hello, Frank, and hello, Thierry. It's Frank Anton and Thierry Albrecht. They are working for Siemens. Most of you, when you're in electric flying over the last years, know Frank. And he was there for electric propulsion. The electric propulsion has been sold to Rolls-Royce, but Frank is still there as he loves aviation. So I hand it over to you, Frank. Let us know what Siemens is now doing for the eVTOL world.
Yeah, really. Thank you. It's a pleasure. I will share my screen. And okay, screen sharing does not yet work.
Screen sharing is allowed. It should be okay, because like most of the others, or a lot of other speakers like Florian shared it before. Ah, now it's coming. It's coming.
Now
perfect.
It's coming.
But
very good.
This is not the presentation screen. This is a work. Ah, okay. Perfect.
Here we go.
Now here we are.
Go. So title of my talk is Fly It Before Building It. And obviously here we are talking about the digital twin. And the second line of the title may be a little bit provocative, certify it while designing it. Obviously, this is a question, but it's also maybe pointing towards the future. And what I'm going to talk about is the accelerator called Accelerator portfolio that Siemens has, the comprehensive suite enabling the digital enterprise. What I'm going to talk about, first of all, I'll speak a bit about the challenges that you have when you go from traditional air travel to urban air mobility. Then a little bit about my personal, but our experience that we have had from flying, how the digital twin really expedited our development. Then I'll speak a bit about Accelerator that I just mentioned, which is the suite of the digital twin and the digital thread that Siemens has in its portfolio, and show you some examples about how to fly it before building it. So the challenge is when you go from traditional air travel to urban air mobility. First of all, obviously, we use electric propulsion, and the big benefit, I've always said the benefit of electric propulsion is to be able to distribute the propulsion. You can put the thrust vectors at points where with shafts you never could do it, but now with electric cable you can do it. And in my opinion, you only want to build an electric aircraft if you also want to participate from what gives you distributed electric propulsion, number one. Number two, we are talking about power density, obviously, for these propulsion elements, but we are also talking about energy density because we want to have a useful range. And this is why, in my opinion, hybrid electric aircraft will be the broad application in most cases. Obviously, there are niches for pure electric, which by themselves are very interesting and sometimes very deep and broad niches. But for most applications, it will be hybrid electric, either using kerosene or using e-fuel or using hydrogen. And there are very interesting projects with hydrogen and fuel cell. Dimensioning of the electric machines, for example, is more driven, not obviously by the electromagnetic effects, but even more driven by the thermal management of the components. The inverter integration, by the way, yesterday or the day before yesterday, Florian Hilpert from Fraunhofer told us about how much mechatronics, how much the mechanical part dominates the integration of an inverter. So the electrical, electronic, mechanical integration via software is very important, is a key. But then it also comes to automated flight operation, which certainly, and I loved the word eVTOL that we learned about this morning. The automated flight operations, you will immediately ask for, how can I early determine whether my sensors work, what do my sensors see, and can I simulate that, and can I understand how the system will be at the very beginning. But then it's also about the business model. How do you deliver the whole logistics? When is which aircraft where, and where is it going to be charged, and how does the network work, and all these questions within the, let me call it, passenger experience. Also, this is something that with simulation, with the digital twin of the whole enterprise, you can very early design. And then, you know, and you believe you are ready, you are close to ready, then it's of course about verification and certification. And there is this famous factor of pi. A project in aviation always takes a factor of pi more money and time than you anticipated. And if it is not an order of magnitude, but only a factor of pi, then you may be considered to be good. And verification and certification, if you have it in the process from the beginning in your design, in your digital twin, in your digital design, then you have a good chance of finalizing the project successfully. Now, let me talk a little bit about the experience. And we had, for example, the Magnus eFusion, which was a 70 kilowatt continuous powered electric plane. And here, by the way, you can see the plane turning left base for landing at the at my home airport, Hetzleserberg, here next to Erlangen in Germany. And how could we bring this aircraft so quickly into operation? By really using the concept from virtual to real. From a virtual concept to a virtual product to a real product. And yeah, now I'm going to show you all the inside views and all the mysteries and simulations of these components. Oops, I forgot. I sold the business Siemens e-aircraft to Rolls-Royce a year ago. So obviously we also sold all the IP to Rolls-Royce. So unfortunately I can not. So somehow I have to change the concept of my talk, and maybe I just speak about the experiences in application and tell you a little bit about the practical advantages that we had from simulation. So this is 2 out of a fleet of 4 Magnus eFusions that we had at that time, and we flew more than 300 emission-free flight hours. And by the way, you can see me here in the second plane as the wingman. I did quite a bit of the flight testing myself and have about 49 hours of electric flight in my personal logbook. So again, to be such fast, we were using, of course, multi-physics simulations. And here are 2 examples. In the bottom line, you see the design of an electric machine, of a motor, coming from electromagnetics, and the very important part of the thermal and the cooling, but also the acoustics leading to the integrated performance. And on the in the top line, it's the battery system coming from the cell design, from the chemistry, the integration, the cooling, the control. And here you see an ugly control system in the large area of automotive, where of course this software is widely applied. I, as a pilot, of course, love the user interface, the human interface of an aircraft much more than this one. And again, this leads to the integrated performance. And only with these multi-physics simulations, simulating everything at the same time, all the effects, then we were able to really get fast to the early flights. And just to take one other example, acoustics, there are so many factors in acoustics which generate noise, and noise is probably the most important thing in electric vertical takeoff and landing. There's the structural noise, there is the noise that is just coming from the fluid, but also which is coming from the fluid coupling with the structure. Then there is the turbulent flow, which by itself makes noise, but also makes noise by exciting vibration in the structure. And obviously there is also noise generated by electromagnetic fluctuating forces in these electric machines. And to simulate all these noise factors at the same time is of utmost importance if you look at the acoustics element of the flight. So a few examples of what we could only do by simulation. This is probably the smallest inverter that has ever driven an electric plane. It has a height of only 47 millimeters, which is much less than 2 inches. And with a weight of 0.9 kilogram and more than 100 kilovolt amps, it has 116 kilovolt amps per kilogram. Of course, there were all these aspects of thermal, electromagnetic, and simulation. And only by simulating all this, we were able to get very fast a permit to fly. On the left-hand side, you see that in one of the Magnuses, we integrated this inverter, we connected it instead of the normal inverter, which is just one of the boxes that you see here, one of the big boxes. And I actually flew 1 hour with this plane with this inverter. And yeah, the only way to get there so quickly was by simulating with the digital twin before. Another game changer that was only possible by early simulation was the, at that time, strongest electric aircraft in the world with 260 kilowatt of continuous power. We integrated this into the extra 330, which was called LE for electrical then. And it was very fast. With simulation, we were so fast that it only took us like 7 months. The handshake with Walter Extra I had early December, and in July, just 7 months later, July 2016, Walter did the first flight of this strong electric plane. A couple of months later, FAI world record time to climb, and 2 world records in speed, one for less than 1,000 kilogram, one for above 1,000 kilogram, which to my knowledge, all 3 are still valid records. And also this plane and Le Bourget in the main air show every day tout the plane, the glider plane with Nicolas Onon in the air at a level of 1,000 meters with approximately 10 meters per second climb rate. So this at that time was also the strongest towing plane, electric towing plane, I think up to now that I know of. And one other thing that Martin Freiling showed us yesterday, Diamond Aircraft, the world's first hybrid electric twin engine plane. This plane, it was to me a very important project because again, when we talk about electric, hybrid electric, we talk about distributed propulsion. If you are not using the benefit of distributed propulsion, scratch your head and ask yourself whether electric is really needed. Or in turn, if you go electric, use the capabilities that distributed electric propulsion give you. So if this is the claim, then it was absolutely necessary to try a kind of distributed propulsion ourselves, and 2 is at least more than 1. So we built this plane with 2 very small electric motors and the big generator in the nose of the plane, as Martin explained very precisely yesterday. And if you look at the plane, then you can see that these propellers are really very close to free stream propellers. So the integration efficiency of these 2 propulsors is much better than the one that you have when you have a big engine in the nose of the airplane. And you can imagine that also such a plane, to build such a plane and to get a permit to fly and to bring it in the air safely goes much better, if not to say is only possible if you study all the effects in a multi-physics digital twin study before you really go to flight. So with these experiences from what we were involved in when e-aircraft was still Siemens, I can now turn to a picture that is very important. And what is so important here is that the real world and the virtual world are coupled to each other. And this not only in the design phase, but this also in the production phase and also in the along the lifetime of the real product. And so to say, the virtual world has to be calibrated against the experience that you make in the real world with prototypes in the early design phase and with products during the lifetime of the product. And if you do all that, then with the accelerator portfolio that Siemens offers, this is really enabling the digital enterprise based on a collaboration platform of all these elements of the suite. And to give you again an example that is close to our hearts, then here you see on the top left, within the Sim Center portfolio, which is part of Xcelerator, you see an integrated system, which top left consists of battery, electricity, electric control, inverter, motor, propeller of a quadrocopter, and also the flight dynamics model. And all of this is 1D, as we call it, in AIMSIM. And then on the left bottom, you have a more detailed electric flow thermal submodel of the battery, which then, by the way, is integrated in the top model on the top left. So if you click on the top left, then you will find the details of the bottom left, more detailed model. And then when you switch to the mid bottom, you see a detailed CFD thermal model of a battery, of this battery with all the air cooling, fluid cooling, etc. And all that is in the CFD is integrated into the 1D on the left. So that shows the scalability of the whole suite, of the whole digital twin. You start at a high level and you go into more detail, even down to into the details of the CFD. And the detailed model then updates what you have in the system level and 1D calculation. And in the mid top, you can see a CFD-based optimization of a UAM configuration, to improve the performance and reduce the power consumption, etc. And this is, and now I have it move, it's an automated optimization capability. It is a parametric digital twin model. And while you see these things moving, and then you see different setups of potential UAMs with different lengths and widths of the different parameters. And the CFD calculation tries to find the optimum. So this is the one thing. And the other thing on the right-hand side, this is a like City Airbus-ish Siemens quadrocopter model, flying from Munich Airport to our site Siemens Perlach in Munich. And this model has a 1D AIMSIM system model behind. So the size is, it's sized on the City Airbus, and it is sized on the parameters on the on public information that Rolls-Royce gives about the parameters of the RP 200D. And it is coupled to an obstacle avoidance control system, which we also have in the portfolio, which gets input from 3 LiDAR sensors. They are positioned on this aircraft. And in the lower movie, you see what the LiDAR sensors see, so to say. And in the mid, you see the curves which show the torques on the props. And so in this scenario, it flies to the New Perlach site. And then all of a sudden, there is a crane in the way that was not communicated. There's no NOTAM. And the question is, can the integrated system with battery, etc., electricity, avoid the crane and remain within specification of the electric system? And if you now think you are in a project and you are before maiden flight, and you are still left with a failure mode for which where the probability is low, but not low enough. And you have to mitigate this, and you have to prove that there is a mitigation so that you can enter into first flight. And then you do ground test, and you try to have the inverter fail in the ground test and to show that the mitigation works. And you have maybe to do this several times, and each time you kill an inverter, and it costs a lot of money and time. And if now you are able to do additional of such tests in a digital twin, where you combine everything from the system and also the flight performance, the mission profile, then you can destroy as many inverters as you want during these trials, and you can get results which, if they are coupled to the real experience of prototype, then give the authority a much better confidence about your results, so that they may give you the permit to fly even earlier. So SimCenter that I have been talking about is the most comprehensive digital twin that I could think of, which goes from the structural performance through all the elements, multi-physics, but also cabin comfort, passenger safety, reliability, up to integration, verification, and certification. And SimCenter, if you will, is the engineering part of the whole suite. So SimCenter talks Newton, it talks Bernoulli, SimCenter talks Maxwell. And Accelerator, the whole software suite that we offer, of course, has more to it. SimCenter is a part of it. Other parts are the digital thread, to name Teamcenter, to name Polarion, and others. So with this complete suite, you really get a comprehensive digital twin. You get a competitive advantage, and this is probably what we all want. But thinking of our heart, what we all want is fun, and what we all want is flying. So let me finish with a picture from Grenchen, where we had a beautiful, wonderful formation flight in which also the Phoenix and the e-Genius were involved, and Klaus Ullmann talked the other day about the wonderful e-Genius. And on the right-hand side, you may be recognizing the two guys, and they look like they had fun. So if you have any questions about our flight experience or about SimCenter, then you can always address Thierry, who is always also in the call. Thierry Olbrechts is responsible for the SimCenter Aerospace Solutions, or you can address me, send me an email, frank.anton@eaircraftconsulting.com. And by the way, if you have any questions about the technology inside the propulsion systems, ask my very good friends at Rolls-Royce. Really, thank you.
Thank you, Frank. And with this presentation, we are about to close our eFly forum, but we have Q&As, and I think we definitely have, at least I have some questions. So if we can unshare your screen, then, oops, yeah, here we go. And oops, not yet. And then, so what we will do now is we will have a quick Q&A session. Then we will have a quick breakout room session where people can ask directly questions to you three. Perhaps also the other speakers of this session could join, because like Corvin, Bianca, and Florian. And then after this session, we definitely say goodbye. We won't take your time any longer. But I will give you a short outlook, and also my partner, Ms. Chen, who was organizing very great the Chinese side of this electronic first online eFlight forum. She will also address you. And then I have a little gadget for all of you who still don't have enough from electric flying, which will be an electric flying chill out room. I will post the link for this room here in the Zoom session before we close the Zoom session. So, but now first, anybody has questions on this? There was this session. Otherwise, perhaps I start, and then I see if there are some other questions coming in. Question to Bianca from DLR. Is DLR, when you're doing this kind of research, are you working together with companies, or is it purely academic research what you're doing there? So if you find out that an eVTOL should look like this and that, would this then go directly into companies' consideration?
Well, the project that I talked about today, HorizonUAM, that is a strictly internal DLR project, so it's a pure research here. We are cooperating with NASA on the same topic, and that is related to that project. But of course, we have other projects at DLR, European project, LUFO project, and there we have strong collaborations with other industry partners as well. So not directly in HorizonUAM, but in other DLR project, we are cooperating with industry.
Okay, thank you. Frank, I have a question on this. So it seems to be one side, your project is the Sim Center is in a way theoretical, but on the other way, do you have already, let's say, from the eVTOL, e-aircraft world, other companies which are using your tools for saving time? Frank, I think Frank is muted. Yeah, we're working on this. Yeah,
okay, now I think I was able to unmute. But I would really like to pass this question to Thierry. Thierry, my friend, would you be?
Could you unmute Thierry? We work. Actually, I should be able to do this as well.
Yes. Yeah.
Okay. Oh.
Yeah. Do you hear me?
Yes. Now we hear you fine.
Perfect.
Sorry.
Well, absolutely. So actually, as this market is forming, we put in place a special program, startup program that basically allows to offer all these different digital twin and digital thread capabilities to our customers and to a lot of the startups. And we have been seeing a lot of companies, for instance, e-Aviation is using our tools, Lilium is using our tools, Volocopter is using our tools. So we are actually, I believe, on quite a lot of the companies that you have seen really here in the presentation. I believe that we have some or the other digital twin capability. It's also very important to state that it's not only about simulation, of course, it's also about the verification side of it. And there we do have solutions. For instance, I'm referring to the presentation of Professor Holzapfel, where we have a lot of capabilities to do acoustic testing, to do structural dynamics testing, flutter testing, as well as we have the digital thread capabilities to keep all that data together and to allow to keep all the traces of the proof, the evidence that you basically put in place towards the authorities, to keep the traces from the requirements up to the verification.
Xin, it's you. So Xin, you have a question from the Chinese channel. Can you please?
Yes, actually, we received 2 questions, actually 3 questions for Frank Anton, I think. The first question is, how is the price of Sim Center compared with other similar industrial design tools, such as Dassault's Simulia? And the second question is, oh, sorry. Okay, we're going to unmute.
Again, a good question for Thierry. Huh?
Yes. So, of course, we have quite a lot of friends in the market that offer similar tools, but where we believe we are very strong is that, first of all, we can create that virtual integrated aircraft view from very early in the concept phase until the verification phase. So we allow to basically, whenever you have an electrical system, maybe with a hybrid electrical system combined, whether it's the power plant, the fuel system, the hydraulic system, we allow to basically create that integrated thermal energy level view from very early till very late in the development. Secondly, we do not only look into, let's say, the development of the products in a virtual way. We absolutely realize that in context of providing the elements that will help you in the certification, in context of providing the proof of compliance, that you need to combine the simulation world with the testing world. And we believe that as long as there will be innovation, as long as you are going to use additive manufacturing capabilities, maybe you are going to use a very high power electrical system atypical for the aircraft of today. Well, as long as you are going to innovate, you will have quite a lot of questions on how did you model it? Did you take the right approach? Did you do the parameterization right? And in that context, the handshake between the virtual world and the physical world is so important that we adopt both approaches. Of course, Siemens invests in making it possible to make as good as possible, as accurate as possible, virtual models that support you in the virtual testing. On the other side, we do realize that a lot of testing, that a lot of your companies will have to face a lot of testing in order to prove it to the authorities. So we make it possible to really make the handshake between the virtual testing and physical testing and keep all that data together. It's not only about digital twin, it's not only about testing, it's about how do you keep the traces to all the data that your company is generating in context of the certification.
Yeah, thank you very much, Antiaki. I think the next question is still is for you. I think someone is asking in the chat room that how big is the difference between using any standalone software and using SimCenter? Because I believe SimCenter is a cloud-based. So I think that's the question.
So SimCenter allows to, as already said, to integrate more of the physics together, to keep it in context of your CAD models, etc. That's very important. And can you just repeat the question, because I believe I missed part of it? Sorry.
The question is what's the difference between using a separate standalone software, design software, and by using SimCenter?
Well, when you use, let's say, a different system for the hydraulic system and a fuel system and the electrical system, it's very difficult to basically integrate the physics and to come to a better understanding of that integrated thermal balance of your integrated aircraft. So if you are using a different tool for your environmental control system that is being used to ventilate the cabin on one side, but also cool the avionics equipment, if you are using a different tool than for this part of the system, and if you are using a different tool for the electrical system, these different tools typically talk difficultly with each other. We are very open, by the way, to integrate also competitor tools in our capabilities, but we do believe, of course, that our integrated approach is much more better. Also, our capabilities, SimCenter has a lot of standard off-the-shelf libraries available, which allows you to really kickstart very quickly and to keep the learning curve quite low.
Yep. Thank you, Antti. I think we've raised quite some inquiries or interest in the SimCenter. So here's another one. Which cloud service is SimCenter based upon? Amazon, SAP, or Microsoft, or something like that?
With respect to that, we have different solutions, and we can offer our solutions on different cloud providers.
Thank you. I think
but that needs to be discussed in detail with the customer, of course.
Yeah, I think all the audience who are interested in Siemens SimCenter can, I believe, can contact on your presentation, right? So.
Yes.
So yeah,
my contact
I have
details
a question to Corvin, which is on your D3 system you're working on. It would be that there will be a box or something, some interface installed into the aircraft. Would this kind of interface has to be in every aircraft? Because we still will have other aircraft. We will not only have eVTOLs, we'll still have like planes like Frank or me are flying, or yourself. I know you also have your small plane. Has this somehow to be integrated in the system, or will the system be able to also work with outside?
Well, we heard from Bianca today that eventually these systems will have to be such that traditional air traffic and the new air traffic can operate together. Eventually, there will have to be some technological solution that links all these, the conventional traffic and the upcoming traffic. And quite frankly, the systems on board conventional traffic today will not provide for that. So the answer is, in order for future traffic to be fully integrated, yes, I do believe there will be additional avionics required on all types of aircraft, both the new upcoming eVTOLs and the traditional aircraft, again, if they need to be fully integrated. At this point in time, we do believe that our system requires specific electronics or avionics on board participating aircraft. We also do foresee the ability to monitor and integrate on a planning level so-called non-participating aircraft, but that will be limited to a certain volume. So fundamentally, in order to play in the system that we are suggesting, dedicated avionics will be required.
Okay, understood. Question to Florian. You are working on fly-by-wire system, on control systems already quite a while with your university research. How is this, where do you see is a chance for certifying such a system due to the redundancy requirements of EASA and others? Because I think especially for the eVTOL, it's essential. A conventional aircraft, you still can say I have a backup control, but for an eVTOL, I think without electronic control, it's not possible.
So the good thing is, in my opinion, that EASA with the eVTOL, and especially now with more and more details on the different means of compliance, has taken a clear stand there. So I would say on the regulatory side, the direction on the framework is quite given. And so in the end, I don't see any big showstoppers to the certification there. So from my personal understanding, the most critical point are really the engine control units, because in the end, you can only accept the loss of one, or in some vehicles, maybe two of the lifting engines. And the problem is, of course, that you don't have a sufficient level of redundancy when it comes to the motor controllers. And therefore, I would say one of the things which I would suspect that many are tackling on is the electronic architecture in the motor controllers to, at least on the low power side, have their a sufficient level of redundancy, like triplex redundancy or something like that in the motor controller. But beyond that, I would say that everything should be covered, and I don't see any unsolvable challenges, which is reflected by the fact that so many people are going in this direction currently.
Okay, thank you. I have a question to Thierry, Corvin, and Frank at this point, because, or especially first to Corvin, a system like yours, when I heard what Frank was telling, normally in such a system, you also would work with a kind of digital twin, as I understand, because you have to simulate what can happen for giving the systems the time to react in the right time. Is this correct? And are you thinking in this way in your software development?
Absolutely. From my point of view, the concept of digital twin has two significant applications in developing future air traffic control. The one is in the development phase. How do you simulate the algorithms that you are using for the system and simulate total system behavior? The second significant aspect is that we believe that a type of certifiable digital twin needs to be actually integrated into the operation of the system, where the totality of required information is stored and is accessible in timeframes that allow for intelligent decision making. What do I mean by this? If you want to make decisions on air traffic management in real time in a complex environment, you have to make sure that all elements required for making that decision are available at the right time with the right frequency and the right level of credibility and redundancy. So that in itself represents a digital twin that houses that information at any given point in time. So the answer is absolutely, we see multiple applications for this type of technology in our approach.
Okay, thank you. Can you unmute Frank? Wait, I see if I...
Okay.
Yeah. Ah,
It's that is very important, and the example that I've shown with the avoidance, the obstacle avoidance of this quadrocopter, yeah, clearly in this very moment the system has to overtorque the engine, has to overtorque the propeller. It becomes less efficient, so it has to even more overtorque, which is a nonlinear process. And as you rightly said, Willy, it's about is the system able to give this overperformance in this very moment to do the obstacle avoidance? But it goes beyond. It goes beyond. Yeah, the digital twin also has to test what are you left with afterwards, after this event. Yeah, there is more heat now in the system, and there is less energy in the batteries, and more heat in the batteries. And so what kind of flight performance can you use during the continuation of this flight after this unexpected event is also something that you can test with a digital twin. And why is the digital twin so good? Because there are so many different ways how the system could malfunction and how unexpected events could happen, that you cannot test them all in the real life. But you can test many of them, much more than in real life, with the digital twin. Okay. Maybe Thierry, you also want to add something?
Yeah, we unmute him in a second. Yeah.
Okay.
Yes.
Just a small addition. We call it the executable digital twin. If you have a well-calibrated, during your development, if you have a well-calibrated digital twin, you can make it real-time available on the systems. And just imagine what you could do with, let's say, the executable digital twin and the physical aircraft when you can compare during the flight or after the flight, even for maintenance purposes, when you can combine, let's say, when you can combine the information that comes from a nominal flight represented by the executable digital twin and the real physical flight, when you compare the data with a lot of data analysis techniques, you can find actually very early on what kind of system might be wearing sooner than what you have expected in the development or based on your experience. So it even goes beyond, let's say, the applications, Corvin, that you have been talking about. And yes, we can do that.
Okay, good. So very interesting, I think. And so I also, if one of you has a question to each other, no problem, just ask it. On the other hand, I think as it took a little bit longer already than we thought, and people have time planning, we're still in a working day. So I should suggest we start one more time our breakout session where each of you will be in one room and people can join, and we'll make sure that this time you can join if you have the latest Zoom client in. So with this, first of all, I have to thank all the presenters who has done with a great presentation from around the world, and nearly same or same as much also Miss Chen, who just appeared and now she disappeared again. Miss Chen, she is coming. Yeah, hello, Miss Chen. We haven't seen much during this event.
Yeah, okay.
So we have translation enabled again. So if you come out of the breaking room, you can switch on to the right channel to understand. And Miss Chen, it's yours.
OK，大家晚上好。为期3天的网上论坛我们马上结束了。首先感谢蓝创联盟和德国飞越公司。
Flying Page, GmbH, and also Z-Park Sky Innovation General Aviation Industry Alliance. I want to thank our regulators also, and also want to thank our keynote speakers from both at home and abroad for your spectacular remarks. I want to thank all the participants and attendees for your support of our forums. I believe that we all get a lot of takeaway. We do believe that the high-speed development of technology really a great propellant. And this year we've talked a lot about hydrogen energy, and we are taken by surprise by the high-speed development of the hydrogen energies, from government policy support to our eFlight from Ruixiang, and from Comac, and the Autoflight eVTOL, and China's eFlight development is running side by side with the world sometimes, or we can say that the gap between China and the world is still narrowing, and that is the goal of our eFlight forum also. I believe that domestic Chinese practitioners, companies, higher education institutions and research institutions, they are into this market by leaps and bounds. And also we were attracted by a lot of investors in this sector. And what worth mentioning is that last year we have set up the airworthiness committee, which was supported by multiple stakeholders, which yield great result, and also gain support by the government, by regulators. So the committee has become one of the major pillar for the eFlight, become the bridge between regulators and private entities. So on behalf of Z-Park, Sky Innovation General Aviation Industry Alliance, we want to welcome more people to join us. The year of 2020 will soon come to an end, and the new year will begin. I hope that during the 14th five-year plan of China, we can have more newcomer, new unicorn companies to join us in the eFlight industry. And we hope that the vision will come true in the future, soon or later. And I really hope, thank you for your support. Thank you. Okay.
Thank you very much. This was very quick. And I was even not fast enough to unmute my microphone. So like said again, I also have to thank the people you see on this side here, our sponsors, because without them, Rolls-Royce, Volong, and Bosch, we wouldn't have been able to realize such a forum. And I would like to, also thank my colleague Xin, who really has done a great work and a lot of day and night working, because you can imagine we have to organize everything in 2 time zones, and even sometimes with America in 3 time zones. So it's kind of working around the clock. And thank you. So for a very last time, for 3-4 final remarks, I will share my screen. I just want to give you a little outlook and what we are doing at Flying Pages when we are organizing this, because you can imagine from this kind of event, it's difficult to live. So mainly we do magazines, and with these magazines, in the year of Corona, we started also a web channel. And in this web channel, I mentioned this 1 or 2 times, we also have discussions like this one, but on one subject and very focused and much longer time. So let's say it's 45 minutes, one session where you can talk more and we can go more in depth to persons who have interesting things to say. When you see on this channel, which we established, which is the eFlight Garden Talks in the eFlight Journal channel on YouTube, you also will see and find the recordings of this eFlight forum, because we will have the Chinese ones in a Chinese channel and the English ones in an English channel. So if you contact me by email later, I will have on the last slide also the coordinates, then you can contact me, and then it's perfect. And we will send you all the information and where to send the information. And also, if you want to get in contact with one of the speakers, we'll put on this site also the PowerPoints as we have them. And so you can have and follow up with the eFlight forum for the future. And we also will give you updates, and depending on the health situation, how long we have to be more digital than real. So as long as it's necessary, we will do it. And we also learned something. So perhaps in future, we can combine a little bit the digital world and the real world. So we'll have more people joining into our real conferences by digital, because this in the latest time before, sometimes was a problem that people told me, yes, I want to go to eFlight Expo, but it's always at the same time than Sun and Fun, so I can't make it. I didn't make it for 10 years. Now they could do. They just take 2 hours and they got into our conferences. So having this said, these are the next events coming up. Like always at the end of the eFlight Forum, you have the QR code there at the bottom, which you can scan, and then you can get information on these events, which is the eFlight Expo at Aero in April next year. I hope it will take place in reality. We all hope it. We have the vaccine now, so we hope it's getting better. So at the moment, we are planning for having a real Aero, not a virtual. But if it would be necessary, we'd have a virtual eFlight Expo again. Then we have the next year's eFlight Forum, which is already planned. And we had so much planning, which we have already invested before, and then finally didn't take place. So we had to have the eFlight Forum online, which from my point of view, worked quite well, because I always like it when I learn new things. And I learned quite a lot of new things from the speakers. So thank you very much for this. So these are the WeChat codes for contacting myself. And the other one is the contact code for Willy Tacke for having my coordinates. So if you want to contact me at Flying Pages, just scan the codes or take the email address, send me an email and I'll answer it. It will take a little while after the event, because first we have to be a bit to recover. Second, we have to cut the videos and to select the PowerPoints and to have the reports in our magazines, because all these events will be covered, or all the speeches which are new and interesting topics will be covered in our magazines, mainly in the eFlight Journal, which you were seeing at the beginning of my short presentation. With this, I go to the last stop. So officially now the eFlight Forum is closed, and we prepared a little chill room for you. And this chill room, it's a new software. It is quite new, and I will post at the moment. I posted in the link to everybody. No, I didn't post to everybody. I have to, now I post it again to everybody. And if you join this link and follow up, you have to close Zoom, you follow the instructions, you go in there, and then you have a room. And in this room, I hope you see your mouse, my mouse. You can walk around. You have a little avatar. You can, and as soon as you approach to somebody, you can talk with this person. And if you want to talk with somebody more in private, like with 3-4 people, you go to one of these tables with the chairs, and there can be up to 4 people at this one, for example. And they go there, and you can, as soon as the 4 places are occupied, nobody else can hear, nobody else sees you, and you can have a private talk in there. So with this, I would, yeah, there is one more point here, is a little stage where you can go and then speak to everybody if you want to do so. So I will be there as soon as I close the Zoom session. If you don't have any more time, thanks for joining. See you soon and stay healthy. Thank you very much. How can you get eFlight Journal? Just scan the QR code on this page, or just type in your browser www.eflightjournal.com. Then you receive the page with the latest online news on electric flying, eVTOLs, and everything which is connected with electric mobility in the air. Or you can click the link on the top, and then you go to the latest PDF version, which you either can read in the Yumpu reader directly on your screen, like a conventional magazine, or you can go and download the magazine as PDF file so that you can read it offline wherever you want. Thanks for watching, and goodbye.